Okay, so we're back at 2.2, solving linear equations. No, we still are in Algebra 2 here, even though that solving linear equations is something that we really should have mastered in Algebra 1. But we're gonna add a couple of things onto this one, so just bear with me. Solving equations, just like in Algebra 1, I usually put in my tracks to help me stay organized. We're solving for x, so our objective is to make sure we get x equals down here at the bottom. I like my x on the left-hand side. That doesn't mean that you need to manipulate it that way. 3x is equal to 21. Divide both sides by 3. X is equal to 7. Now, B, all of a sudden you cringe and you say to yourself, oh my God, there's fractions. We all know it's the F word of mathematics. But the thing is, let's get rid of the fractions. So what I'm going to do is look at my denominator, which is 3. 3 is the only denominator I have here. If I had more than one, I would be multiplying them together. So we're going to multiply everything by that 3. This by 3, this by 3, and this by 3. Now, you can also kind of, instead of doing that, you could just say, well, I'm multiplying the whole thing by 3 like this. But some people will get confused by that. So sometimes just multiplying every term by 3 is helpful. So we multiply every term by 3. Now my fraction cancels out, and I get x equals 3x plus 12. And now all of a sudden, a sigh of relief. I hear it. I hear you sighing like, oh, that's so much easier. So now I'm going to isolate my x on the left side because that's within my comfort zone. So x minus 3x is a minus 2x is equal to 12. Divide both sides by negative 2. This part is cake because you guys have been doing this forever. X is equal to 6. Moving on to C, a couple of different ways we can approach C. We can put this over 1 and we can cross multiply. As long as you have an equal sign, you can cross multiply like this. So you would get x plus 8 is equal to 2 times negative 6, which is negative 12. So that's one way you can do it. The other way you can do it is exactly the same way I was just explaining to you in B, where I can multiply both sides by what's in my denominator. As I do this, these cancel and I get x plus 8. 2 times negative 6 is negative 12. So you get to the same point. So at this point, we are going to minus 8 from both sides. And x is equal to negative 20. Hopefully you're saying to yourself right now, wow, I hope the rest of the course is this easy. So now D means we have to use a little of the distributive property here. Please make sure that you are being careful with this because I will tell you that even the most experienced math teachers will, or math people, will make mistakes here. So make sure, and I actually do my loops. So I make sure that I don't forget to multiply, because that's what we're doing here, we're multiplying both terms inside the parentheses. So 6 times x is 6x. 6 times a positive 4 is plus 24. Now beware, that 2 with the subtraction sign, we're going to treat that as a negative 2 because that's the same thing as plus negative 2 times x minus 1. So it's going to be minus 2x plus 2 is equal to 2x plus 20. So here we have our tracks. And the next step is going to be to combine like terms before we do anything else. Because before we start flip-flopping over that equal sign, we're going to pull anything together that are the same. So we're going to rewrite this one. 6x minus 2x is 4x plus 26 is equal to 2x plus 20. Again, my next step is going to be to subtract the 2x. I always move my x first. Consistency, by the way, makes everything a little bit easier. So however you choose to do this, do it the same way each time, so that way you're not making silly mistakes. The next thing I do is I move my numbers over here. I get 2x is equal to negative 6. Divide both sides by 2, and x is equal to negative 3. Sorry, I didn't give you enough space there. Now, hopefully you also realize if you had to do something silly like this, that you can very easily check this before you moved on. You can either use the store button in your calculator, or you can simply just put your negative 3, substitute in for the x, and just do the math out and make sure that the left side is equal to the right side. All right, pause at this point, finish writing down what you need to before we move on to our next topic here. Okay, so this part might be a little bit new. Some of you might have seen this in Algebra 1, but I'm not sure if you did, talking about what an inconsistent equation looks like and an identity looks like. So, an inconsistent equation is an equation that yields no solution. In other words, it can't work no matter what number you put in there. An identity is exactly the opposite. It's true for every number. No matter what number you put in there, it will work. So, that sounds kind of cool, right? All right, so on the left side is an example of an inconsistent equation. So let's just do the same thing we did before, and so we're going to try and solve this. So we have 6x plus 6 is equal to 6x minus 20. All right, so I mean, the next step I think I would probably do is minus 6x, but I'm kind of hoping you see that already these cancel and you get 6 equals negative 20. Well, no matter how hard you tell 6, it has to be negative 20. It won't be negative 20. So this is called an inconsistent. So at this point that we had this, when we had that 6x plus 6 is equal to 6x minus 20, already when you have the same thing on both sides of the equal sign, you can just cross them out. So no matter what x we put in there, we're never going to get a solution. So this, we would call this inconsistent, or we would say there's no solution. Now an identity, when you solve an identity, you're going to do the same thing here. You get 8w minus 4 is equal to 8w minus 4. So again, when we have the same things on either side, we can cancel them. We can cancel these. We can cancel these, and we get 0 equals 0. So this is called an identity, because no matter what value of w we use, it'll always work in that equation. All right, so that's called an identity. And sometimes you'll be asked, state whether these are identities or inconsistent or neither, because if you can actually solve it, it's going to be neither inconsistent nor an identity. All right, so moving on to exercise 2. State whether the equation is an identity or inconsistent. I'm thinking or neither. That wasn't here, but that is a possibility. And when it says justify your answer, it means show the math that proves what you're saying is true. So we're going to solve this just like we did in Algebra 1. And we're going to do 6x. Remember, we're going to think about that as being a negative 2 minus 2x minus 8 is equal to 3x plus 6 plus x minus 5. Before we move on, we're going to combine like terms on either side of the equal sign. So 6x minus 2x is 4x minus 8 is equal to, here we have 3x plus another x is 4x. We have plus 6 minus 5, which is plus 1. So as you can see, because we have the 4x's on the same side and they're the same sign, they're going to cancel out. And we're going to get negative 8 is equal to negative 1. Positive 1. So this is inconsistent and has no solution. All right, justify your answer. We answered the question. First thing it says, state whether the equation is an identity or inconsistent. We answered the question right here, and then we justified our answer right here. So we're okay. We answered the question properly. Write down what you need to, and let's move on to exercise 3. All right. So this is just a bunch of equations that we're going to see if they're identities. Are they identities? Are they inconsistent? Or are they neither? Which means they solve. So why don't you pause at this point and try and solve some of these before moving ahead. Or maybe even do like A and B and then play the video again and see the solutions to that. All right? All right, so pause. Looking at B, yeah, you can multiply everything through by 2, but I think the first thing I want to do is isolate my fraction. And again, this is very personal. You don't necessarily have to do this first. So you get 4x plus 2 divided by 2 equals 2x plus 1. And now multiply everything through by 2. So multiply this by 2, this by 2, and this by 2. So you get 4x plus 2, because that's the reason we did it, to get rid of the fraction, is equal to 4x plus 2. Well, right away you can see this is an identity. Beware, make sure you're distributing that negative to everything inside, which changes the sign. Well, this one's looking promising. So this one is neither, because it solves. Now, if they want to get rid of that 5 first without, I moved the 2 over. I would usually add 2 to both sides before I multiplied through by 5. But in this case, let's just multiply everything through by 5. We're going to multiply this by 5 and this by 5. So this becomes 5m minus 15. This is if you like to get rid of those fractions right away. So when we multiply this by 5, it becomes 4m minus 10, right? Because you multiply this by 5, the 5's cancel. You multiply this by 5, that becomes minus 10. And now we're at the point where we can solve this pretty easily. So this again is neither, because it solves. last two. So again, if you want to multiply through by that 4 first, you can do that. And that will get rid of the fraction right away. So you get 8x minus 4 is equal to 3x plus 36. I'm sorry, yeah, that's right. Okay, the 4's cancel, that's right. So minus 3x minus 3x, again, looking promising here. 5x minus 4 is equal to 36. Add 4 to both sides. 5x is equal to 40. X is equal to 8. So this is neither. And this last one. Again, you can multiply through by 4 first, but I think I'd like to do some playing around with that left side before I multiply through by 4. So this becomes 2x plus 1. I'm going to distribute this. Plus 2x minus 2 is equal to 16x minus 4 divided by 4. So combine like terms and I get 4x minus 1 is equal to that mess, 16x minus 4 over 4. And then we're going to do, now we can multiply both sides by 4. Multiply this by 4, multiply this by 4, so those 4's cancel. And I get 16x minus 4 is equal to 16x minus 4. When they're exactly the same on each side, this is an identity. So I'm hoping that with spending some time and trying to master solving equations like this with fractions, you have a little, your comfort zone's getting a little bit expanded with using fractions, all right, and being able to determine whether these are inconsistent, whether they're an identity, or whether they're neither. All right. So again, I seriously think you can do this independent practice on your own. So I think I would like you to do that and then come in so we can discuss what the answers are with your people in the next class. Okay? So until next time, always make good choices and be safe.